We're going to do percent, fraction, decimals, and ratios. Okay, and they're talking about similar pairs of shapes. Okay, so what they've done in the book there is we'll draw. They have, let's say, a rectangle. In this rectangle, what they want you to do is actually measure its length and its width. Okay, so what would you say the length of this rectangle is?
3.
Yeah, okay, so we're going to say 3, and we'll call them centimeters. And the width or the height?
2 centimeters.
2 centimeters. That's right. Now, to have something that is similar to this, you have to set up the same type of ratio, okay, to it. So a similar triangle, in terms of a ratio, could be something like this. Oops, wrong button. Something like this. So, what is the measurements of this rectangle?
6 centimeters.
4 centimeters. Okay. So these are similar. They're not the same shape. Okay, but they're similar shapes. Because if we set it up as a ratio, okay, this ratio is what for the first one?
2 to 3.
Yeah, 2 to 3 is the first ratio. So we have a 2 to 3 ratio. And what about on our second ratio?
4 to 6.
4 to 6. That's right. So if we have a 4 to 6 ratio, is there any way I can make one ratio the other one?
Reduce 4 to 6.
Yeah, we can reduce 4 to 6, right? So even though they're different sizes, they have a similar pairing to them. Okay, so they still work like that, and that's what they mean by similar pairs of rectangles or shapes. Okay, does that one make sense? Okay, again with equivalent ratios, we have a ratio of 4 to 2, right? So let's say I have 2 happy faces for 1, 2, 3, 4 stars. Okay. Now, if I want to make an equivalent ratio, what can I do to those two numbers here, 2 and 4?
Multiply by 2.
Sure, let's multiply by 2. So what I'm going to do is I'm just going to do a little times 2 times 2. What is my new equivalent ratio going to be?
4 to 8.
Yeah, 4 to 8, right? And that means it's for what? What were the shapes we had?
4 happy faces and 8 stars.
Yeah, okay, so 1, 2, 3, 8. 4 to 8, okay, and that works out fine. And there's another equivalent ratio. What else could I have done to these?
You could divide.
Yeah, divide by what? Yeah, so I could also divide by 2 for both of these, right? And what would my equivalent ratio be then?
1 to 2.
Yeah, so we'd have a 1 to 2, which would give me,
1
what are
happy
the shapes?
face and 2 stars.
1 happy face and 2 stars. So what's important here is we look at the ratio. Our first number in the ratio always refers to what?
Refers to
What are these?
the
Happy faces, yeah. And the second number in the ratio is referring to our,
stars.
okay. Now, if I were to write the ratio, I'm going to do it in green here, 4 to 2. I'm using the exact same numbers, okay? Exact same numbers. But I want you to look at the ratio now. Look what happens. If our first number refers to happy faces, and our second number refers to stars, are these two equivalent ratios? In the first one, what do I have more of?
Yeah, we have 2 happy faces and now you have 4 happy faces.
So look at this. I put a line through the top. I just want to go over the idea here. In the first ratio, do I have more happy faces or more stars?
More stars.
Yeah. In fact, can you tell me how many more I have?
You have 2 more.
2 more. Okay. What if I was to multiply? What would I be multiplying by?
2 by 2.
I'd be multiplying to get from 2 to 4. I'd multiply by 2, right? That's the idea from here to here. Okay. What about in the second one? What do I have more of?
You have more stars.
And how do I get from the happy faces to stars?
Multiply by 2.
That's right, and multiply by 2. And again, what about in this one? Oh, I did draw. I forgot to draw an extra star there.
Multiply by 2.
Yeah, so if you notice in this ratio, I'm always, from the first number to the second, I'm multiplying by 2. Now in our second set of ratio, I'm going to write the same numbers again. So we had 4 to 2, or there's a possibility of 8 to 4, or like we said before, 2 to 1. Okay, Now, these numbers are all the same. They're just in a different order, so you would think they'd be the same ratio, right? Well, let's think about the faces. 6, 7, 8, and 1, 2. In these ratios, to get from the first number to the second, what do I have to do? Oh, now is that the same thing? No. And is it the same thing here? No, definitely not. And here? No. And what's important too is I want you to recognize is that in all of these, I'm going to write it down here, we had more stars in our top set. And in the bottom one, what do we have more of? More happy faces. So are these equivalent ratios? No, because the number we have of each is very different. We had more faces on the bottom, but we had more stars in the other one. That means these definitely can't be equivalent ratios because they're not equaling out in the end. Okay? Did that make sense?
Yeah.